Hello everyone. So you're doing the lab called Limiting Reactants on Pivot Interactives. So we've done the pre-lab questions, then you went online to collect some data. You have your data table filled in, now you want some help with the calculations. Now, let me do this. I'm going to fill in the data table for trial number 1, which we had in the beginning video there. Now, the first line says mass of the empty beaker. That was the beaker with nothing in it, 82.78. The second line is the mass of the filter paper all by itself, 0.68. Line 3, the beaker with the silver nitrate in it, that would be 95.11. The beaker with silver nitrate and water, that's after they stirred it and it's all dissolved, 185.18. The beaker with silver nitrate, water, and copper in it, that's just at the beginning of the reaction, 186.90. The dried filter paper with the silver product, that would be after it's been left to dry overnight, 6.52. And the last line is the mass of the leftover copper after the reaction. Well, in trial number 1, there was no copper left. We'll put 0. All right, let's take a look at the calculations. Number 1, write a balanced equation showing the reaction between solid copper and aqueous silver nitrate. So we have copper, and we could say solid, plus aqueous silver nitrate, AQ for aqueous, yields copper nitrate, now that's CuNO3 taken twice, plus solid silver. All right, the copper nitrate remains as aqueous. To balance it, we need some coefficients. We need a 2 in front of AgNO3, a 2 in front of Ag, and that will leave us with a 1 in front of everything else. There it is, balanced equation. Number 2, for each trials, determine the mass of each reactant. Now we have 2, copper and silver nitrate. We need to take a look at our data table. Here we are for trial number 1. Now, the mass of the copper and mass of the silver nitrate. This would be for trial number 1. We'll just put in number 1 right there. All right, first, the mass of the copper. All right, now we have the beaker with the water, silver nitrate, water, and copper. That's got everything in it. And then we had the beaker with everything except the copper in it. So we just got to subtract to find the mass of the copper. 186.9 minus 185.18 gives us 1.72 grams of copper. Now, the mass of the silver nitrate. So we have the beaker with silver nitrate and water. No, we have the beaker with silver nitrate, and we have the empty beaker. So again, just subtract. 95.11 minus 82.78 gives us 12.33 grams of silver nitrate. Now, question number 3, for each of the trials, determine the mass of silver product produced. Here we've got the mass of the filter paper with the silver product, and we have the mass of the filter paper with nothing on it. Again, subtract 6.52 minus 0.68. 5.84. That's the mass of the product that we produced, silver. On to the calculations. Number 4. Using the mass of the copper used for each trial, determine the mass of the silver solid that should be produced if all the copper was reacted. Now, you'll have to do this calculation for each trial 3 and trial 4, but we'll do it for trial number 1 here, at least give you some hints for trial number 1. All right, the mass of the copper that we started with was 1.72 grams of copper. And we need to figure out how much silver that should produce. A stoichiometry problem that's going to end in grams of silver. Now, you'll do that for trial number 3 and trial number 4 and figure out how much grams of silver you would make if all the copper got used up. Question number 5, using the mass of silver nitrate, determine the mass of silver that should be produced if all the silver nitrate was used up. So for trial number 1, we started with 12.33 grams of silver nitrate. And we want to know how many grams of silver that will make. A stoichiometry problem ending with grams of silver. Grams of silver. 3 steps. You'll have to do it twice. Once for trial 3, once for trial 4. For question number 6, for each trial, which of the 2 reactants is the limiting reactant? To answer that, we would have to look at the answer to these 2 problems. Whichever one gave you the least amount of silver would determine the limiting reactant. All right, now that's going to be different for each of your 2 trials, so you'll have to find that out. All right, if all the copper was used up, you would make this much silver. If all of the silver nitrate was used up, you would make this much silver. Whatever one is the smaller one will determine which is the limiting reactant. And you would say, why? Well, whatever one makes the least amount of product. You could also say it's the one that ran out. In one of those reactions, trial 3 and 4, one of the reactants ran out. You could see it. Now, once you have these answers, the one that's the smallest one is going to be your theoretical yield. What is the theoretical yield and the actual yield of silver for each trial? Now, for trial number 1, the theoretical yield is going to be whatever answer is smaller for number 4 or number 5. The actual yield we calculated in question number 3 using your data. The mass of the actual yield of silver we calculated in number 3. So for this case, 5.84. And the theoretical is the smaller of answer number 4 or 5. What is the percent yield then? The actual yield goes on the top. The theoretical yield goes on the bottom. Times 100 gives you the percent yield for each trial. You'll have to do that for trial 3 and 4.